Thanks.
Cool, thank you guys.
Okay, well, welcome everybody. I'm Nienhuis. I'm a front-end architect here at Advisory Board. And just a quick note, we are hiring. And I don't know if we should do that.
It's all right. We can do it after or...
Okay. Yeah, so, you know, to what Praveen was saying, we're all kind of still learning. This is a pretty new group. For me personally, I had some questions around how dependency injection worked with Angular, and I had some confusion. So I did some research, and I wanted to share this back with you guys, and just kind of take a look and talk about dependency injection. Alright, so dependency injection enables something called IOC, inversion of control. And inversion of control is a design paradigm that gives you more control to the targeted components that you're writing in your application, the ones that are actually getting the work done. So, you know, usually when we design our applications, we build a lot of our logical control kind of in the top part of our application, and then as we build and we get to the lower components, you know, those lower components oftentimes are doing a lot of the work. So inversion of control is a kind of a design paradigm that flips that relationship and gives more of the control inside the targeted components that you're writing. Excuse me. So dependency injection is the design pattern that it removes hard-coded dependencies and makes it possible to change them at runtime or compile time. Dependency injection, it allows us to remove those dependencies from our application code, and it keeps our components more decoupled. And inversion of control relies on dependency injection because we need some sort of mechanism that can actually activate those components and put them in our application. And we're going to look a little deeper into later on in the presentation to understand why that's beneficial and how that helps us write a better application. So, and then just so we keep the terminology straight, when I say dependencies, I also mean components and I also mean abstractions. They're kind of synonymous. So in other words, this big long quote. But basically the two things to really point out here is that that with inversion of control, our dependencies are instantiated by some kind of assembler. And then those dependencies are located by something called the service locator. And it's important to understand those two things because that's really what makes dependency injection work really well. And I'll send out this presentation later. I tried to link everything that back to kind of where I read about a lot of this stuff, so handy as a reference. Okay, so in AngularJS, we have something called $injector. And $injector is a service locator and an assembler. So it enables dependency injection for us. This is from the docs. Injector is used to retrieve object instances as defined by provider, instantiate types, invoke methods, and load modules. So the injector service knows where our dependencies are located, and it knows how to assemble them. And most of the work is invisible to us, but it's good to know how that works because it really clarifies how the framework works all together. So this is also from the docs. This is always true. So we get an injector off of Angular, and this is just a very simple unit test. But we use injector.get, and we define a dependency injector, and it goes and gets injector, and we compare it to injector, and that will be true. that comparison will always be true, and the next line will always be true. If we invoke a function and pass in injector and return injector, it's going to be injectors. Basically testing the actual mechanism of dependency. So it's just kind of interesting to see that just at a very simple level. And I've kind of tacked on at the bottom there, there's one injector per application. So injector is a singleton. So this is the API for injector. We have injector.get, which is everything that ends up getting located ends up using this off of the injector, and it returns whatever it is that you're looking for. Injector has is just a simple check. And then the next two, instantiate and invoke, are kind of assembly methods, and they do exactly what they sound like. Instantiate instantiates, invokes invokes, and it'll make a little more sense as we progress. But the API is really simple, and those four methods right there make a lot of stuff happen. If you dig into the core, it really comes down to those four quite often. All right, so now we're going to look at the provider, and this is the other piece that's really important. I may have been a little bit ahead of myself. All right, so this is from Understanding Angular Dependency Injection, which is an excellent article. The provide service is responsible for telling Angular how to create new injectable things. These things are called services. Services are defined by things called providers, which is called when you're creating when you use provide. So injector locates and assembles our dependencies, while the provider tells the assembler how to build them. And when we write Angular services, we're using the provide API to define our dependencies. So these are the things that we're familiar with: the factory, the service, the value, the provider, which is very confusing. There's a provide service singleton, which you can actually define a provider on. But we're about to dig into that a little more. So injector plus provide equals the entire dependency injection implementation altogether. These two make it kind of all work. So does that make sense to everybody?
No.
If it doesn't, you are totally screwed. You might as well get up right now.
Get the fuck out of here.
Can I ask a question? I mean, I'm assuming that the provide means that when you say provide, that basically you're saying I want to provide a service. I mean, that's where the actual verb comes from, right? So that would be a function that would be called by by some code that wanted to provide a particular service.
That's absolutely right. It's an API,
That's what's good.
and it returns those things that you want to define. That's exactly what it is, and we're about to go through them and see. Think of this, that $ provide, as nothing more than an API that does stuff, that returns stuff for you to define things in. And the injector, the way that when you define something behind the covers, it interacts with injector for you, so you never really have to use injector directly.
So the provider is sort of like a registration service for the injector, if you want to call it that way.
Yes.
So it's define the object. Is that used to find the object or some object?
It
or
does
to create an instance of that object, or
it does do the so provide will make it known to the injector where to find it. However, injector is what ultimately does the binding when you decide to use it in a controller or something.
So if I have two implementations of a particular service, I'll call provided exactly one.
Sorry, say that one more time.
If I've got two different implementations of a particular service, or n different implementations of a particular service, I'll use $provide to recommend one of those which injector will then use. So if I'm mocking a database, for example, I'll give the mock through a provide. And when a database is called for, it'll show up as a.
So in that particular use case, I would say you use provide and declare a decorator. And a decorator is a mechanism that you would use to decide what service dependency to return. And internally, it would use injector. But let's just move on right for now,
Okay.
because the next couple of slides will I think tie things a little bit more together. So I was just kidding earlier, by the way, about does it make sense to everybody, because this was a lot to wrap my head around personally. But so one quick note also, all this API that we're looking at is exposed directly through the module as the module API as well. So whenever you bring in a module dependency at the top of your file, you can call these things directly on the module. You don't have to inject, provide, and do stuff. It's just kind of a shortcut. Okay, so the first thing we need to look at is the provider off of provide, and it registers something called the provider. Everything else is derived from this, so it's really important to understand this first. So here we have a block of code where we're going to define what a provider is. We're going to say app.config. We're going to inject the provide service. We're going to define provider. We're going to call our provider function, greeting. We're going to pass in a function. Inside of our function, we're going to declare a greeting, and we're going to add a change greeting method onto the function body, or the scope of the function. And then this last part, this $get equals function, is going to define what is the actual thing that we're going to want to return as our dependency whenever we inject it into something else. So the provider is probably the most complex service you can use, and the reason why it's the most complex is because it gives you it has the most. One way to explain it is it has the most levels of scope attached to it. In this outer function, if we go down here and we say app run and we inject greeting and we invoke Bob, we're going to get hello Bob. Because up here, by convention in Angular, any object that you register with the injector that has $get defined on it, the injector is going to assume that is the dependency, that is the functionality that you're trying to either instantiate or invoke and pass into your function. But with the provider, so we see this .get equals function, and it's going to return a function when it looks up that says alert greeting name. And down here, if you say greeting Bob, it's going to say hello Bob. So when you define a provider, one of the added benefits you get is down here, it automatically creates something called a greeting provider. The greeting provider is a reference to this outer level function that we defined when we initially defined our provider, and that's kind of like a opportunity to to configure your service. So down here we have app config function greeting provider, and we're going to invoke change greeting to salutations. Up here, it's going to invoke this .change greeting. It's going to change the greeting variable in our local scope to the new greeting. And when we run and inject greeting again, we say greeting Bob. It's going to say salutations Bob. So providers are kind of the main way to define what it is you're trying to build.
So this $greeting provider is dynamically constructed based on just greeting, and then it appends the provider on the end of it?
Right, it just kind of auto-magically creates it in the background. So provide. So I did mention the injector service. It calls a provider's get function in order to return the instance of the service every time you inject it. It's really important to realize that, because that pattern is so powerful in Angular. So provide.service name constructor. So this is a shorthand way of calling the previous provider. So here's what, essentially, if you looked in Angular core, it looks something very close to this. When you define a service, what you're doing is you're just saying provider.provide, and you're defining directly into this.get, but you don't have to write the code out. So it's a provider without the configuration of a provider. That's how I would think of what a service does. So that first function block is kind of the synonymous definition of it in terms of using provide and stuff like that. The next function block with app service greeting is what we would use. We define greeting, we pass in the function, and then we, do whatever we do inside that function. I mean, we either return something, or in this case, we have this.greet. We're actually defining a method into the instance of the service. So down here we say app run function greeting, greeting.greet Bob, hello Bob. Or let's change our service definition just a little bit. App.service greeting function, return function name, alert hello name. Notice now in the next block we're saying, now when we inject greeting, we directly invoke greeting and it outputs Bob. So you can see how there's a little bit of, you can define your objects a little bit differently. I could have even returned a straight up value instead of a function, and then you wouldn't be able to invoke it when you inject it. But the main thing is that service is just a little bit more shorthand than provider, and you can't configure a service like you can configure a provider. And then the factory. So factory is also a shorthand for defining a service. The difference is that the injector instantiates a service, whereas the injector will invoke a factory. So, in other words, when you inject a service, injector's going to say, when it assembles it, it's going to say new service. So when you return a function, it's going to say new whatever that function you return as your definition and instantiate it. A factory, on the other hand, will just simply invoke, the injector will simply invoke it, and that will be the value. So there's a small nuance there. So synonymous definition in the first block. Second block, defining greeting once again. This time we're gonna return an object literal. We run greeting.greet Bob. It's almost the exact same thing, really. I mean, these are just such minute differences between these two different structures. And again, I do the same thing I did last time, change the definition a little bit. The factory can just return a function, and then now your injectable dependency is simply an invocable function. So value, this is the value service. So this is a even more shorthand way of defining a service. Basically, you're defining a function directly on the get as if it's already a constant. So the injector is not going to invoke it or instantiate it. It's just going to take it as is. So first block, synonymous. We see here app.value greeting. We pass in a function directly, and boom, that's what the value is. You say app run, inject greeting, and then do greeting Bob, hello Bob. We just achieved the exact same thing again, except it's just less code.
Is there a dollar sign missing up there? Or am I just confused?
So,
which says provider value on the first line of code. Should it be dollar provider value?
Yes, I think yes. You're right about that. So yeah, I think, and then provide.constant is technically not a service. it's a little bit different because it does not participate in the same injection scheme that the other 3 things we just covered do, 4 things rather. So you can't, but for some reason you can inject it. The difference between a value and a constant is that a constant you can inject into a configuration function, kind of like the provider, the greeting provider, for instance. You can inject into that, but you can't intercept it and decorate it. So you define a greeting constant, and by the way, this would work. From my perspective, this works exactly the same. If we were to say app value, we would get a very similar functionality. So we run the function, it says greeting Bob, and we're good. Here's the decorator. This is honestly something I haven't used yet a lot, but I had to include it because it's part of the API. But it's pretty cool. You can imagine some pretty cool things. It basically does a decorator pattern, which is if you don't want to modify your dependency, your component, whatever, your service, you define this decorator and you target it. And what you do is, inside, you could say if you define, so you want to define a decorator called greeting, and you pass in delegate and the injector. Delegate refers to greeting. If some condition that you don't like, you can return another dependency. You don't have to return greeting. Otherwise, return delegate. So now when you inject greeting, internally this decorator is going to do something, and it's going to give you a different dependency if whatever your body, if your condition isn't met. So I can imagine some interesting applications there, but I haven't personally used it. Okay, so that's the provider.
Could we go back to the decorator? Because, I mean, I think, earlier the question was if I wanted to dummy up a database, and you mentioned a decorator, and I was waiting then to hear about the decorator. So if you could, you said you didn't have any immediate use for it, which I understand, but I mean, explain to me the thought that you had when you said, oh, I think I'd use a decorator for that. I mean, if I was ordinarily going to call something and then I wanted to see, have a dummy function for testing, I mean, how could I use a decorator to pull that off?
Let's say you have a data service and you inject it all over your app, and this data service is responsible for grabbing your data and making it available to your controller. What you can do is you can define a decorator on that dependency that you inject everywhere in your application, and you say, if global flag dot production mode or testing mode equals true, instead of returning the original API that does all your AJAX calls to whatever backend that pulls live data, instead return a testing harness that calls a bunch of mock data.
Okay.
And there's other ways, that particular problem you just described, there's other ways you can solve that in Angular. I mean, that's just, I guess, a thought that popped into my head.
Sure. No, I just wanted to understand.
Okay.
Thanks.
Yeah, sure.
So basically, just for clarification, right? So when you say production value is equal to true, right? So that would be replaced by that some condition in there in that code.
Yes.
And then you basically return your object which you're looking for.
Yes. And by the way, whenever we're done with the slides, we're going to review some live code and actually see an implementation of some of this stuff, and I think it'll make it a little more concrete. But I will make a quick note about require.js versus AngularJS. So require.js gives you this ability to pull in dependencies externally, which enables you to do IOC, but technically, on its own, it doesn't really qualify as a dependency injector. And I'm sorry, excuse me. Just kind of go off my notes here. So, so require.js is a service locator. You define a dependency and pulls it in. But what it doesn't do is it doesn't assemble your dependencies for you. It doesn't instantiate them or invoke them. So that's something you can implement in require.js, but you would have to do that implementation, and it would be vastly inferior to Angular, which makes it available everywhere through the framework. So I think it's interesting to look at that. Just further reading here. So where can you inject stuff? Anything, you can inject it into anything where injector invoke is used. Includes controllers, directives, factories, filters, provider get, defining something in provider's get method, or a provider function, or another service. And what should you use? So what should you write your services as? Should you use providers, services, factories, or values? This is, I think, the original question I asked myself. It's like, what do I use? What should I use? I think the answer I found is it doesn't matter what you use, because everything is derived from provider anyway. It's just more or less code in the end. But I think the longer answer is, if you want to decentralize the configuration of your service, then you should probably use a provider, because it builds in a pretty nifty way to configure your service. And then this is huge. All of the Angular services you write are singletons. That means they are unique. So if you're injecting it everywhere and in your controllers and you think you're doing something that's unique to that controller, you're not, unless you handle that in your implementation. That's a really, that really killed us. So if you need unique instance data in your service, I would say consider either using an internal dictionary in your service, or write your service as a function constructor, which Angular UI does quite a lot of. I find that they make a lot of that pattern, use of that pattern. And then what to abstract as a service. Dependencies you need to test. So it makes it very easy to swap things out for mocks and stubs. Everything, I think you should abstract everything. Any kind of data service makes an excellent service to write as an injectable service. Reusable things, and also everything. I think one thing, if you haven't gathered this from this presentation, is that dependency injection is like one of Angular's best features, and if you're not leveraging it really hard, then you're not really getting the full benefit of the framework. So hopefully dependency injection is a little more clear, but in case you want to review it or look over it, this is a list of links to look at that are really, really good, very long-winded, well-written explanations of dependency injection. And so before we go to code, I just want to take a moment and see if you guys had any questions.
Are your slides on the meetup site?
Not yet, but they will be. This is slide.es, so they're already live.
So we can grab it right from that URL, right? You don't need a password or anything.
No password. Sweet. Public stuff.
So you said is Decorator the way to inject mocks and stubs in this, or does Angular provide something to this?
So,
Yeah, I'll give you a list of his.
so you could use a decorator. If you want to internally, I would say decorator would be excellent if you want to internally implement something that has some sort of test flag that you can flip on and off from somewhere else, and the decorator just automatically kind of makes that happen for you. In general, I think dependency injection allows you to, it inherently keeps your logical components in your application already decoupled. So it's very easy to, like, say you're trying to test a function, well, you either bring up another, in your testing framework, you just inject the things that you want to test and then you work with that. So those things are pretty easy to drop in somewhere where you need to write some kind of like end-to-end test or a unit test or something like that. Or if you're just doing smoke testing in development, you can also directly in that metric, swap it out with something else that you want to, use as a test harness. Honestly, there's a lot of possibilities, and I haven't fully formed all my personal opinions on what is a really good solid testing strategy. I think that would be an awesome meetup. If anyone wants to tackle that, would love to learn more about that, but I think those are just some general approaches.
Just throwing this out there, going back to your decorator example about using it to swap out service, web service and other REST service. If you're going to test things like that, Angular has a thing called HTTP backend, and they have a mock for that built for doing tests, which allows you to do a bunch of other things like expect URL and things like that, which might be better than doing a decorator for testing.
Yeah, I was actually going to ask, you didn't talk, I don't think, about like the inversion of control container. Like, I don't know how, so I'm not that familiar with Angular, but I'm sort of more generally familiar with IOC, like in other frameworks. And so generally, the point of injecting a dependency is that the function using the dependency doesn't care whether it's real data or fake data. The IOC container is responsible for actually like resolving it to whatever it's going to be concretely. And that's typically how you would, typically there's like a container. I don't know in Angular how that works, if there's something analogous to that or whatever. And then like the decorator thing is typically used when you can't modify the dependency.
Right. That's very true.
That's the whole point of the pattern itself, is to wrap, your own code around something that you cannot modify the internals of. So that's the whole point of that. So like typically doing the production versus test swapping or whatever, I wouldn't personally think of a decorator for that. I would think that the IOC container is sort of responsible for resolving that based on whatever your business rules are, elsewhere, not at the point where you're actually, calling your function or whatever. But yeah. My question really is within Angular, I don't think you really touched on that, and I don't know if there is something analogous to like the container aspect of IOC within Angular.
So like, I think that's a really excellent point. So honestly, like with the IOC containers, the best thing that I can compare from my own personal experience is an inject with in a .NET project, and it's really hard to, it is pretty hard to compare like JavaScript to strongly typed language, and like an IOC container solves. With an inject in specific, I think it implements all the things that you need to do the IOC pattern in a strongly typed kind of environment. So I don't think it's hard for me to draw exactly the direct analogy from the IOC container to Angular, but the way, at least from what I was reading off of it, injector kind of was responsible for doing the composition. So I guess if I could try to compare it to anything, injector is that kind of, that container that handles that. And yeah, I don't know how best to really address that. I don't really know how to answer that question.
Well, I guess sort of conceptually, I'm probably not alone in terms of, I think there's a high-level piece that I'm sort of missing, which is like the whole point of dependency injection is that the resolution of the dependency, that aspect of it, right? So the implementation at the function level, which is a lot of the examples you showed, like that's all cool, but I'm still kind of missing like where do you actually, because like my understanding is that you would define, say, a production service that hits your database, and then you might create the same exact service but as a mock that, you know, hits something else. And then the whole point of DI is that somewhere, whether it's an IOC container or the injector, I guess maybe, or whatever, but there's somewhere that based on like configuration or something, it knows that based on the current environment that I'm running in as a container, that I know to choose this service rather than this one, right? And then it passes it, and then that's what goes into like all those examples that you showed. But I'm sort of missing like where does that actually happen, the resolution of the dependencies.
When you define an Angular application, you define the application as a whole, and you start with one module, and that module might be kind of maybe the piece that you're missing in